Hello and welcome to the Srijan Wednesday webinars. For those of you who are joining us for the first time, this is a community initiative by Srijan Technologies where you can tune into a variety of sessions across the fields of technology, entrepreneurship, and community building. In today's session, we are joined by Andrew Berry and Juampy NR from Lullabot. Andrew and Juampy will be taking us through the three key continuous integration frameworks, Jenkins, CircleCI, and Travis. They'll look at the pros and cons of each and help make a business case for CI to business stakeholders. Before we begin, I would request all participants to please type in any questions that you have during the presentation, and we'll take them up in the last 15 minutes of this session. Also, please don't forget to take this conversation live on Twitter using our hashtag SrijanWW. Now that that's over, let's get right to it. Andrew and Juampy, over to you.
And I am a senior architect at Lullabot, and I'm joined today with my friend and colleague, Juampy NR. Juampy, would you like to introduce yourself?
Yes, thanks, Andrew. Hello, everybody. My real name is Juan Pablo. Nobody calls me like that except my mom. Everybody calls me Juampy. Juampy NR. Those are my last name initials. That's my username in social networks, and I work at Lullabot as well. I am a senior web developer.
And if you're not familiar with Lullabot, we're one of the first Drupal agencies founded in 2006. We've done a variety of work with many large enterprises and even smaller websites here and there too. And throughout all of those projects, one of the things that we keep coming back to is this idea of continuous integration. And between Juampy and I, we've got over a decade of experience working on Drupal sites where some of them have absolutely zero continuous integration, and some of them have a lot going on. And we both sort of come down to this this core idea, which is that continuous integration is about building more software with higher quality, but making sure that that software is viable and usable and delivering business value for a longer period of time. But we've also seen that continuous integration implementation requires a lot of management to make sure that you're addressing the sprint products and financial risks that they bring to your project. And if you ignore those risks in your planning and just start bringing continuous integration without thinking about the impacts it has on all three of those areas, it makes it much more likely that your implementation is going to end up becoming a failure.
Did you change? Right. There was a little bit of lag. I like to set the boundaries of what sort of continuous integration we're going to cover. When I looked at continuous integration in Wikipedia, what you get there is a very generic definition. It really doesn't tell you what you're going to get with it. In our personal case, I remember that me and Andrew, we shared an initial idea with the rest of the Lullabot team at a team retreat. I think it was like a year and a half ago, where we were saying, look, in 90% of the projects where we work, we end up implementing continuous integration, regardless it's a client requirement or not, because it just helps us to build better software and more solid. And then in most of these cases, the client, after some time, sees the value of it and wants to keep it and wants to adopt that as part of his team's workflow. So while it's a very good thing, we realize that it takes a long time for us to set this up, and we have to start over on each project. So until not long ago, we used to use Jenkins CI for this, because it's very flexible and it's all open source. So we used it a lot and we loved it. But then while we were just trying to find other ways to set up continuous integration faster, just getting some feedback on those pull requests as quick as possible while you're working on a project. That's when we discovered other tools like CircleCI or Travis, and then there are many others that we also want to try as well and post our feedback. And so this session will be what we went through with these tools, how did we use them, and what are their cons and pros. So here are some of the other tools that we are also using within CI infrastructure, and we'll see that some of these in the screenshots. We use a lot of Drush, Drupal's command line interface. You do things like installing Drupal, importing a database, and things like that. Robo, it's a task runner made in PHP. I personally like this one because I'm really bad at writing bash scripts. I find the bash syntax very tricky. Every time I need to write an if statement, I need to look at the documentation because it's very hard for me. But with Robo, Robo gives you a chance to write your command line tasks in PHP. You have a class with commands. It comes with a few built-in tasks already, and it's very easy. At least it was to me. The Drush team uses it a lot. It's part of Drush 9, so I wouldn't be surprised if you hear more of Robo in the coming months. Docker, we use it to spin up and tear down environments. It's perfect for us to just prepare a place for where we can run a website, and then when we are done with it, either running tests or just playing around with the result inside, then we can destroy the set of containers, and there you go. It saves us a lot of time. Before the Docker days, it was very tricky to spin up a site and then tear it down because you had to create those services and destroy them manually. And then we use Behat for behavioral testing. So here are a few. Here's a summary of what we found out. We'll go into details in the following slides. If a team asks me right now, "Hey Juampy, we want to implement continuous integration. We are working in a Drupal project, and we want to work efficiently and get some feedback in our pull request to make sure that we are doing things right. What tools should we use?" I would tell them to go straight away to either CircleCI or Travis CI. They are very similar. Very similar. Initially I thought that there were more difference between them, but you can do pretty much the same with both of them. So I personally like CircleCI because it's slightly simpler to set up, but you can do exactly the same with Travis CI, and Travis CI has also some strong points, as we'll see later. However, there may be some restrictions in your team. For example, you must keep everything in-house, and so even in those cases, well, you can still use Jenkins. It's still a very powerful tool. But notice though that both CircleCI and Travis CI, they offer you behind your firewall versions, so you can install their tool inside your infrastructure. So it's worth having a look at them. I'm waiting for the next slide. There you are. So let's start with Jenkins. What we see here in the background is a typical Jenkins dashboard where you have a bunch of jobs, and you get a status of whether they are passing or they are failing. Jenkins is great. You can do whatever you want with it. You can automate a lot of stuff with it, and it's an old tool, so there's a lot of support out there in the web. I started using it a long time ago, and it took me a while to get out of it because it's so attractive, especially when you start with it, because it's focused on the web interface. So you create a job, you configure plugins, you create jobs, most of this stuff through the web interface. It also has its downsides because of this, which we'll see in a bit, but still a great tool.
And one thing to keep in mind is that Jenkins does have support for building jobs through your source code, just like how you would with Circle or Travis. But because there's this whole history of plugins with it, a lot of those plugins don't work with these newer tools that Jenkins has, the Jenkins file or the new user interface. So it makes it harder to decide how you're going to implement Jenkins, because you've kind of got two forks of it that you could work with.
So here we have a screenshot of build step. What you do with Jenkins is you create jobs. Let's say one job would be, for example, when somebody merges a pull request against the master branch, I want to deploy this code into the development environment. That would be a job. In this one in particular, we're seeing the screenshot. What we are doing is we are running JavaScript tests against the Docker environment. So what we're doing is we are watching a repository. So every time a pull request is created, we run this script that runs a Docker command against a custom image and runs a script within that image, which is the bit that you see highlighted there. We have this script inside our repository, so we can do version control of it. And can you move to the next slide so we can see the contents of testjs.sh?
Yeah,
there you are. These are the contents. What we're doing here is, well, there's a robot task there to install Drupal. At the end, that's calling Drupal site install within that command implementation. We're also configuring files, and we are starting Apache. At this time, this is like from almost a couple of years ago. Actually, no, a year and a half ago, we were using Phantom.js as the headless browser. Well, nowadays you can use headless Chrome thanks to WebDriver. This is from Drupal 8.5 onwards. You can do this. It gives you a much better developer experience when you're writing tests. And then finally, at the end of this script, we are using behat tests. So that's it. The fact of having the scripts within the repository gave us a chance to, for example, make a change in one of these files and then create a pull request and verify that it worked without having to go into the Jenkins web interface and modify it. So here's a summary of the setup that you need for Jenkins. First of all, you just install it. If you're using an Ubuntu server, for example, you would do apt-get install Jenkins. There you are. That's pretty easy. Then you have to add a few plugins. So among them, you need something to listen to repository changes. For example, if you have a GitHub repository, we have listed here the two plugins that we have used the most. I especially like the second one, generic webhook trigger, because it's very flexible. It gives you a chance to do things when a pull request closes, when a pull request is merged. So I really like this because I could do things like tearing down environments when a pull request was closed or merged. And then finally, once you have this in place, then you have to actually go to the UI and then create one job, another, and there you are, until you're ready with your CI implementation. So let's see some of the pros and cons of Jenkins. Well, first of all, it's free and customizable. You can do whatever you like. There are tons of plugins there to give you even more freedom to modify how your job runs, how does its reporting. Here's a screenshot, for example, where I'm not only showing whether a job passes or not. I'm also using that gray description saying, well, look, your code coverage is not very good because it's at 16%, and you're covering this just for lines of code, but then methods it's even 4%. If this is not the case, but if, for example, a test would fail, it would tell you how many tests would have failed here. We could also extend this to other tasks, and then if you click on the details, then you will see the full job. But this, for example, for somebody who is doing a peer review on a pull request to verify whether things are in place, is very useful. So here's another pro, which is Jenkins has been out there for more than 10 years. Before Jenkins, there was Hudson, another project, which is even older than that. There are plugins for everything. I would be really surprised if you Google for something in Jenkins and there is not already a plugin that either does it the way you like it, or it just needs a little bit of extra configuration or some scripting on top of it to accomplish what you're looking for. Another pro is that since you are in full control of the infrastructure, we found this scenario where we started creating functional Drupal sites using a full database, so we could run had tests on top of the sites. And then we had a QA team who wanted to mix and match different modules and have a working site so they could run the tests against the site. So what we tried was, well, we are building environments and then we are cheering them. We are running tests against them and then we're cheering them down. We could create another job that when you create a pull request, it builds the environment, but then it exposes this environment at a URL within a given port. So what we're seeing here highlighted at the middle in yellow is that we are we're exposing a port of this container, and then in the end what this is doing is posting a comment in the GitHub pull request saying, testing environment is ready, click on this URL to visit it. So there you are. And then when the pull request is closed or merged, then we destroy it.
What's really interesting about this is, I don't know, 5 or 6 years ago now, when we were working on sort of the first iterations of Tugboat, which is a Lullabot product that basically does pull request environments, we actually built it in Jenkins. And that just goes to show how flexible it is. And, in this case, we had really specific requirements around firewalls and access control and so on, where we couldn't use any sort of hosted service. Jenkins is great in that, in the end, it's basically running scripts or programs that you write. So you do have all of this flexibility, including, something like creating an environment that doesn't get torn down like it would with CircleCI or Travis.
And here are some of the cons. While Jenkins is very flexible and easy to install, it requires a lot of setup and tweaking and server maintenance, because the thing is that since you install Jenkins in a server, not only you need to configure all the jobs and keep track of things like memory usage and hard disk space. These kind of things affect the server. So if you write a job in a way that it's not cleaning up properly, for example, it has happened to me in the past, you may end up with the memory full because there are, I don't know, 100 zombie Docker and containers. There was another case where there was a job that wasn't able to clear the workspace, so there were log files, very long log files that were created on every job run that were piling up, and therefore the hard disk space started getting bigger. Anyway, it's something for you to keep in mind, because it's something that you have to check every day. Is Jenkins all right? Is Jenkins all right? And if it breaks, you stop all the CI integration for your team, which is a big thing. So that's one of the big cons. And then the second one is that because Jenkins is so oriented to the web interface, while it's very intuitive to discover what's available in it and to use it, it's tricky to keep that under version control. You'll see yourself many times tweaking a job and therefore breaking it for a while where you're making changes. So it doesn't work for the rest of the team unless you have that same job duplicated and you're making change on the duplicate and then on the other one. But then again, that's a waste of time. So this is also something tedious with Jenkins.
Yeah, and Juampy did mention a little bit about the time it takes to manage a Jenkins environment. because we've worked on it on a decent number of projects, we've actually got some good information about what the costs of running something like Jenkins are for your team. So a bit of a case study in that we had a team that had around 8 developers and 10 or more repositories. In this case, they weren't building a single Drupal site, but this was a team who was building Drupal modules internally for an organization that were then being used by all sorts of other teams for Drupal sites. And on average, we were looking at about 4 jobs per pull request. So coding standards, BHAT tests, unit kernel tests, and which one am I? Why am I blanking on the last 4 jobs? Maybe it was we had unit and kernel tests split up into 2. But on average, we were looking at about 18 minutes total CPU time. So what I mean by that is if you were to run each job one after the other, it would take 18 minutes. And for those 8 developers, each person was submitting 1 pull request a day, but that wouldn't necessarily mean that they submit 1 pull request and it gets immediately merged. They might realize that some of the tests are failing or that they need to do more work. And for this team, it was about 3 commits per pull request that were getting actively tested. So 24 total commits. And the team in this case was running tests locally as well. So in a lot of teams, you're not necessarily running anything locally for a variety of reasons. Maybe you have so many tests that it's just not feasible. Drupal core tests are a great example where it takes an hour or more for tests to run on the test bot in many cases, just because there's so much being tested. And so by running tests locally, it did reduce the number of jobs that were actually being triggered. And it was generally expected that before you pushed, tests were passing all locally. And in this case, and actually in almost all cases with our clients, Jenkins ends up being set up on an EC2 instance in Amazon Web Services. And the main reason for this is that it's the easiest to understand and set up. It's just a server. But there are some downsides to that, like the fact that an EC2 environment is always there. It's not being turned on and off as needed because it needs to be able to listen to pull request webhooks at any time. And it's also not necessarily going to handle activity spikes in your team, like the end of a sprint. Just because we were doing an average of 24 commits a day, that's just an average. The last 2 days before the end of a sprint, before you're getting everything over for finalizing the sprint, was typically a pretty big spike. Or often the day after a holiday, you might have no pull requests being tested over a 3-day weekend, and then everyone is catching up. They really want to get things done, and there's just a bunch that's pushed through all at the same time. And it doesn't matter how big your EC2 instance is, if you just hit the wrong circumstances, you can start running out of memory, having slow jobs, all those sorts of things that you have to manage as a sysadmin. And you're probably thinking, well, the whole point of Amazon Web Services is that you do scaling of some kind so that you're not just running individual instances. But when you look at most Drupal websites that are out there, most production Drupal websites don't have auto-scaling set up for Amazon or whatever cloud provider they're using, unless they're using some sort of hosting service that basically abstracts that away from you. So if you imagine that your client doesn't have auto-scaling for their production Drupal website, then what are the chances they're going to do production level auto-scaling for your Jenkins services, which, realistically, if Jenkins code is down, doesn't mean your website's down. There's not the business case or the drive to invest in auto-scaling tooling for something like a CI environment. So, it does sound like it's the way to go, but realistically, I've yet to see anyone actually bother to implement it. And in this case, we were looking at a 2x large AWS instance of 32 gigs of memory, costing, let's just say, $300 a month. The memory for jobs, each job would change over time. In some cases, years ago, we saw Composer Update taking 3 or 4 gigabytes of memory to run. It's a lot better now, but you have to assume at least half a gig or a gig of memory per concurrent job you want to run. And in this case, we were seeing about 10 jobs at a time was what the server could handle realistically, which, was fine most of the time. But again, like, you're thinking, okay, we could change what the instance is. We can use different types of Amazon instances, but that takes time to do. It takes investigation for someone to figure out what the best services are for your Jenkins server, and that can change over time as well. You get a bad piece of code, and all of a sudden, all of your pull requests are taking a lot more memory, and you have to stop all your development to fix Jenkins. But on top of just the actual hosting costs, I actually pulled all of Juampy's hours from one client project he was on. And we looked at over 15 months, he spent 116 hours where he logged entries that were related to continuous integration or Jenkins setup of some kind. And for this project, there's no migrations, so there was no worries about the data being about continuous migrations, which is something that Juampy does a lot of as well. And when you look at that, you're literally looking at hundreds to thousands of dollars per month spent in engineering costs, whether that's with a contractor or an agency you're working with, or even for your own internal teams. And in this case, this didn't include any of our clients' hours that they were spending as they were actually managing the infrastructure and hosting. So they didn't have that data. We didn't have that data, so I can't give you any information as to how much that was costing. But if you're assuming that you're spending, $1,000 to $2,000 a month just to maintain Jenkins without the actual infrastructure costs on that, surely there's going to be more that you have to deal with. And of course, the other side of this is, figuring out what your team is actually good at. If you're building Drupal websites, your team is probably good at Drupal and PHP and JavaScript and front-end, HTML and CSS development. And if you're on this call, maybe you're really interested in Jenkins or you have experience with it and you have no problem setting it up. But realistically, is that your job description? For all the time Juampy was spending working on Jenkins, he still had to get development work done. And for agencies in particular, after the initial setup is a really important transition as well. Is the client willing to maintain the Jenkins server on their own? Are they going to keep it up to date and secure and functional? Or is it just going to sort of be there until jobs start failing and then abandoned? So when it comes down to it, the costs of hosting Jenkins efficiently are really related to the expertise of your DevOps staff. And so if you want to reduce your Jenkins costs, you have to have really quality DevOps staff. Quality is the wrong word. I'm going to say experienced DevOps staff who have been doing it for a long time. But then you might be paying more for that person on your team than the hosting costs of an unoptimized architecture. And most of the projects we've worked on, that's where things have sorted out, where the DevOps roles tend to be more junior positions within a programming or a Drupal team, but then you're spending more time and hosting expenditures on the Jenkins instance itself.
Let's continue with evaluating CI tools. The next one I had a chance to work on, and it was thanks to Andrew, was CircleCI. It turned out that the client that we were working at that time had already an account with CircleCI, and they were using it for deployments. So we wanted to give this a go for continuous integration. By this time, we were already having issues with memory usage and hard disk space on our Jenkins server. So we gave this a go by moving some of the jobs to CircleCI and see how it goes. Andrew did an initial investigation and moved some of the jobs, and then when he showed them to me, the results were amazing. I didn't know that CircleCI was so good. What we are seeing here in this code snippet is a CircleCI configuration file. This file lives in your repository, and therefore it contains the whole job implementation. This is just an excerpt of it. It's longer than it. We have a repository with all this stuff that we'll mention at the end, hence the link at the top. But still, in this particular case, what we're seeing here is we're implementing the job that runs unit and kernel tests, where this is a YAML file where there are a set of defaults that we are inheriting. This is part of YAML syntax. We'll see the defaults in a bit. And then the steps are checking out the code, copy a robo file where we have a bunch of tasks that we use, and then run a robo command that runs unit tests, and then the rest is CircleCI syntax. Store the test results in display, so CircleCI can show them on screen. Store the artifacts if there are any in displays, so they are accessible from the CircleCI web interface, and then save cache. We are defining our cache strategy further up in this file. This was amazing. Just when I took Andrew's initial work and then I moved that to another project, it took me just minutes, just placing that file, authenticating myself against GitHub against CircleCI with my GitHub account, and telling CircleCI, yes, please watch for changes on this repository and look for .circleci config YAML file in that repository and do what it tells you to do. That's it. As soon as I did that, the next time I create a pull request, then CircleCI kicked in and started running my jobs. This process with Jenkins, normally it would take me a week, like, because there are always complications. Like, to get it as like this, it would take me a week. Or yeah, I wouldn't be more optimistic, because there were always issues with it. I'm saying from scratch, like having to set up server and all that stuff. With CircleCI, there's no server. There's just a file, and you just need to manage that file, and CircleCI will do what you tell it to do in that file and present you with the results. So that's great. And let's see some of the pros with CircleCI. First of all is that you get parallel processing by implementing what they call a workflow. In this case, we implemented a workflow for running unit tests, BHA tests, running code coverage. CircleCI will run it in parallel if it can, because it depends on the kind of service that they are offering you, or that you have, whether you're paying for it or not. But if it can do it, it will do it, and it will run your jobs in parallel, which is great, because it gives you feedback very quickly in your pull request.
Yeah, by default, private repositories or private organizations get one concurrent job, so you wouldn't see anything running concurrently. If your repository is public, you get up to 4 concurrent jobs, so it's pretty easy to play around with it if you want to.
Here are the defaults that we saw in the previous excerpt from the CircleCI config file. What we're defining here are the mix of Docker images that we want to use in our jobs. If anybody who's listening has ever used something like Docker Compose, this must be familiar to you, because what we're doing here is like I'm telling, hey Docker, I'm going to use this custom image that I have on Docker Hub that is called Drupal 8 CI. Internally, this image is just an extension of the official Drupal 8 image in Docker Hub. We are adding a few more things to it, like, for example, Composer. But it's the same. And we're also removing Drupal 8 core, because in this place we are testing a full Drupal site. So we are putting our site in instead of Drupal core. Then we're also using headless Chrome by the Selenium. The image is provided by Selenium. This is for our BHA tests. And then finally, for database, we're using MariaDB. So with this information, CircleCI is able to build environment and connect these containers together. So then we can do something like running PHPUnit tests, or checking if the code follows coding standards, or running BHA tests, things like that. Some of the other pros that we have is that you can access to the resulting environments of a job. Like, let's say, for example, you run BHA tests and they fail. I've seen myself in this case where I'm battling against the CI tool, because it's telling me that a test failed, and I see the failure, and I think it's because of this. So I make a change in my code, commit, push, wait, and then it fails again. And then it fails again, and that's a huge waste of time, because it takes some time. since you make the change and you see the result. You can simplify this a lot by jumping into the environment with this feature and doing your tinkering, figuring out what's wrong, figuring out what you need to set up in the server, and then make adjustments in your CircleCI config file and commit and push your changes. You can also run jobs locally. Since CircleCI builds a Docker environment and run whatever is in your CircleCI config file in it, it offers you a command line interface for you to list the available jobs that you have and run a job, which is great because you see, in this case, you don't even have to create a pull request and wait for CircleCI to run a test for you. You can run the job locally first, see that it works. And because you're using your own infrastructure, you can even jump into the container as it is running. I've seen myself doing it. It's especially helpful sometimes. And then once you're happy with it, then you can commit your changes and push and create a pull request so CircleCI can verify it. What we're seeing here in the screenshot is I'm running a command, CircleCI build, and then because we have implemented a workflow, I'm specifying what job I want to run. And then what we're seeing below it, it's CircleCI pulling the images, the mix of the Docker images that I want to use, and then it will run my steps. So here are a couple of the cons. Andrew, you clarified this, right? It's different for private and public repositories. I wasn't aware of this.
Oh yeah. It's and it's not, it's not very clear from their website pricing page either. But it is, they do have basically what they call their open source discount, and that's in their FAQ if you're working on any open source projects.
Gotcha. So I haven't seen this to be a problem for somebody who wants to start and with CI and try CircleCI for this case. Even if you're running one concurrent job at a time because you have a private repository, you can still get a hint of how easy is this to set up, and then check if you really want to go and try going to the next tier with them, so you can get some parallel processing or change to a different CI tool. So I don't think it's a big problem with it. And then the second one is because this is not Jenkins, because you are using a software as a service, there may be some boundaries, so you'll have to find solutions for them. However, thanks to Docker, CircleCI offers a way for you to build something and do something with what has been built. I haven't found yet a case where I'm like, oh, I cannot do this here. Even for extreme cases, I remember that we showed before the example of Jenkins being able to show you testing environments that can live for a while. Well, while you cannot, we don't know how to do that in CircleCI, sorry, because CircleCI would kill the environment. It doesn't want you to keep an environment on for a long time. If you need to browse against a CircleCI environment with your own browser, you can do that via an SSH tunnel. And if you want more details about this, Andrew is the person who showed it to me.
So as far as, one of the pros though, like looking at the same source of hours, we spent a total of 50 hours from having never used Circle before to having a template that we could use to run in any new module we created that would automatically set up the module for CircleCI. So, it does seem like a decent amount of hours, but it was also a lot more automation than what we had for the Jenkins templates. And what we found was, regardless of that, the maintenance on Circle was basically nothing for most months. And the time that it would come up is a few hours twice a year whenever Drupal core does an update, like when 8.5 comes out. You want to update your base containers so that they're using 8.5. You want to check to make sure that your module tests still pass, all of those sorts of things. Maybe there's PHP upgrades or other things that come along with those containers. But those are still things you have to do with a Jenkins environment as well. So it's really the maintenance comes down to software versus infrastructure. And the costs, being a con in that, you do have to, there is, it can be more expensive to start than a very, very basic Jenkins instance running on a $10 a month Linode. The way their pricing is set up is that you as an organization just decide how many concurrent jobs you want to run. So if you're an agency that goes through projects for clients in a very cyclical cycle, maybe you take 3 months off and you don't really need anything to be done, you can just set your plan down to 1 container and not pay anything. And then when you're doing a lot more work, just spin it up to 4 or 8 or however many you decide you need and pay for that 1 month. I would say that the best way to optimize your costs are to have as many projects under an organization using Circle as you can, because let's just say you're paying for 4 concurrent containers and no one's using them, you're still paying that monthly fee. So if you have a larger organization where there's just enough teams that someone is already always doing some work, then it means that you're basically getting the benefits of the CI hosting without having to pay anything extra.
Let's move on to the last one of the CI tools that we're going to evaluate in this webinar. Travis CI. Travis CI has been out there for a long time, and it's very famous among the open source projects. I've used it in open source projects before. I've never used it against a Drupal 8 site, for example. So what I did is I took what I did with CircleCI and I ported that to a Travis CI implementation. I took the chance to do some further refactoring in the robo tasks, so they would be as, like, everything would be on the robo tasks, and the Travis YAML file would be as simple as possible. Besides, that's what we're seeing here. Travis, the .travis YAML file is like the .circle config.yaml file in CircleCI. It's a file that lives in your repository, that sits at the root of your repository, and that defines what Travis CI should do. It's not much longer than this. Like with Travis, I managed to move a lot of the implementation details into Robo, and I just left the CI specific details into this file. I'm defining a cache strategy here, where we're caching part of the composer files for faster builds. We are enabling the Docker service in Travis CI. Because we are using Docker Compose within Robo. So what Robo is doing is using Docker Compose to build an environment like we did in CircleCI, and then is running a task on top of it. And then finally, I'm using what Travis calls the test matrix to define a variable called job. This variable has 3 values. One is to check coding standards, the other one is to run unit tests, and the other one is to run behat tests. Finally, the script will iterate over each of these values. At the end, what it does, it calls Robo for each of these tasks, and therefore, when you create a pull request, you would see these 3 jobs running, and you will get feedback for each of them. So let's go to the setup. It's identical to CircleCI. You have to either add a Travis YAML file to the repository or go to travis.org and get a template. And then you authenticate with your GitHub account at Travis CI. As far as I know, Travis CI only supports GitHub, while CircleCI supports both GitHub and Bitbucket. So once you authenticate yourself with your GitHub account against Travis CI, then you select your repository, and then Travis starts building. It finds a Travis YAML file and builds whatever you tell it to build. Let's see some of the pros and cons of Travis CI. It's already, I think it's 7 years old. And because the open source communities have embraced it, there are recipes for everything. And I also went through their online documentation, and I must say it's really good. It's really good. It's very clear to read, and there are lots of examples. I really liked it. some of the concepts that I found with it, for example, they mainly are related with a little bit of extra configuration you need to do to get what I'm used to with Circle or with Jenkins. So, for example, if you want to generate coverage reports in your jobs to see how much of your code is being covered by PHP unit tests, and you want to show those reports to the developers, in CircleCI, for example, you could generate this as an HTML report and then expose them as artifacts. You can also do this with Jenkins, but with Travis CI, Travis doesn't have the concept of artifacts. However, there are third-party tools like, for example, this one I'm mentioning here, Coveralls, which it's like with if you want to use it, you just authenticate with your GitHub account at coveralls.io, and then every time and you select a repository, and then every time you create a pull request, Coveralls will see if there is a coverage report in the Jenkins job that you're running, and then it will do both things. It will post a report in your pull request saying, hey, there is, I don't know, for example, an 80% of coverage, and it will post a link that takes you to a web interface where you can see all the details of the report, which is great. They give you a really good developer experience. So after this setup, what you get is really good. It supports Docker, but it needs a little bit of extra setup. As I said, I had to make a Docker Compose recipe for running my jobs in an environment that I could control. Jenkins has a different approach that Travis has a different approach than CircleCI. CircleCI tells you choose your Docker images and you tell me what to do, while Travis is more like, I give you two environments with a lot of tools in them, so you can run your whatever you want very quickly. But if you want something more specific, or you want a more defined architecture, then you can use Docker. So that's what we decided here. And then finally, it doesn't have a command line interface like CircleCI does, but because I decided to use Docker Compose to build my environment, well, I could do this locally too. So I have a command line interface for my jobs because of the way I wrote my jobs. I could just run PHP unit tests using a robot task locally, as I could tell Travis to do it, because it's the same command. Therefore, I'm getting the same experience. Therefore, I don't need a specific Travis command line interface.
So after all this, you're probably pretty excited to set up continuous integration of some sort of your organization, but we've kind of glossed over the human costs or the concerns that will most likely be raised by others on your team or even yourself. And some of the things that we have heard before, we've definitely heard people tell us that tests are too hard to write, that they take too much time, that they are not a good spend of project resources when that same development time could be spent on features, say. And I think even the developers who are giving this session have said this at one point or another. You've probably talked to some people who are from the QA side, and they've likely had at least one bad experience with automated testing, continuous integration, where they were on a project where there was supposedly a ton of test coverage and automation happening, but they still kept finding lots of bugs and regressions that should have been caught by those tests, so that they don't trust those tests. And this is pretty understandable. I mean, the whole point of QA is to not trust the developers when they say something works, because they're there to find bugs. That's what they're there for. You might talk to a project manager and they might say that the time you spend writing tests is time that you're not spending fixing actual bugs. And this comes up a lot with legacy code bases that are really starting to creak and having trouble with delivering quality releases, where from a project management standpoint, the team just really wants to focus on getting things fixed rather than proving you got things fixed. And of course, when you start talking to product owners, they're just going to say that they need to deliver their product that they've committed to on time or on budget or whatever it is that the organization is really prioritizing. And they might not have a direct understanding of how continuous integration leads to delivery. So when you have these conversations, it's really important that you evaluate your project for continuous integration to see whether or not it's a good fit, because there are actually a lot of projects out there where continuous integration might not make the most sense. A good question to ask yourself is the code you're writing, is it going to be used for a short period of time or a long period of time? A lot of Drupal sites are event-driven microsites where they are built over maybe 2 or 3 months. An event happens for another 2 or 3 months, and then the site is slurped up into static HTML and never changed again. If you were building a DrupalCon website, for example, completely from stock Drupal every time, this is a great example where at the end of each conference, you're turning it into static HTML, and that code that you wrote and tested and all that continuous integration you set up is never going to be used again. But if you're writing code that is shared, the easy example is something like a Drupal contributed module where you're writing it, and if you're writing something for Drupal 8 today, it might be used 10 years from now. That's kind of wouldn't be unreasonable to expect. The case for automated testing and continuous integration becomes a lot stronger. It's also worth having discussions with your stakeholders to figure out if the business that you're working with is growing, meaning that you are writing code, you are writing features, and then you are adding new features and new code over time, or whether your business is in a lot more of a flux situation where you write code and it's perfect for today, and then 2 months from now the requirements completely change, so you throw out that code and you write something totally different, and you're in a cycle where you're just replacing and changing that code over and over. Like where you don't have a lot of regression testing makes it a lot harder to justify automated testing or continuous integration. Ease of updating your code when you have bug fixes is really important to consider. If you're writing software as a service where you control everywhere that your code is ever used, then you know that if you break something, it's relatively easy to fix it. But if you're writing code that is then being distributed out to other teams where you have no control over how or when or if they update, knowing that you've got solid test coverage underneath your code makes it a lot easier to say to those teams that what you delivered is what you committed to. And also, it's worth considering if the code you're writing is maybe more of a one-time handoff of code. A lot of times, a central team in an organization will write a Drupal module and then give it to a department or a brand, and they'll never see that code again. So, you want to make sure any continuous integration you set up is going to be maintained and be seen as valuable to that team you're working with. Also knowing where your code is running. Are you running on one version of PHP with just Apache and MySQL and you control the whole stack? Or do you have to deal with multiple versions of PHP, multiple operating systems, multiple websites? The more varied your conditions are, the more value you will get from continuous integration, because then each of those jobs could be one for each version of PHP you support, one for different operating systems, and so on. And planning with your QA team is really important as well, especially when you can have QA analysts who have a strong background in PHP development or JavaScript development, because then it means that they can help in writing those regression tests. If you don't have that model where your QA team is entirely outsourced, entirely siloed off from the rest of your development processes, then you really have to do some careful thinking about how continuous integration works with your QA analysts and so on. So when your developers tell you that tests are too hard, have a discussion about how tests are really just tools and APIs that teach you the underlying systems. And that if tests are too hard, it probably means your underlying code is too hard to understand as well. And if your QA team says that they don't trust the tests, then if you have a dedicated QA team, they need to be completely integrated with development. They need to be on your stand-ups. They need to be part of your sprint commitments. They need to be as invested in the tests as you are. And when your project managers are worried about the time you spend on tests, talk to them about how you're tactical about what to test. You don't necessarily test every single line of code you write in a code base. Be sure that you trust your developers. If they want to write the tests, odds are it's because it's going to make their life easier for fixing those bugs, because they will be able to basically go to their terminal and hit up arrow and know everything works, or push a bug fix to a pull request and know that they haven't broken some feature they weren't even thinking about. And be sure to track your hours, because then you can come back with data to know whether or not the time you're spending on tests and continuous integration is disproportionate to the time you're spending on other parts of your job. And for product owners, discuss how continuous integration is a necessary step towards continuous delivery. And if delivery timelines and delivery budgets are something that they see as very important to the project, then continuous integration is a necessary step to helping them meet their own goals. And something like a hot fix is a really great example to bring up with product owners in terms of how continuous integration can lead to you delivering a critical bug fix in a much faster amount of time without worrying about regressions and so on. So for developers, remember that the testing cycle will be shortened, managing that delivery risk, that the initial setup is going to be as easy or as short as 1 hour and as much as 1 week, which in the grand scheme of things is not too bad. For QAs and PMs, talk about how QA can focus on writing new test cases and not manually regression testing existing ones, leading to an improvement in your product quality. Discuss how your technical project managers will have metrics to share from your continuous integration environments, like test coverage reports, test failures, and so on. For PMs and product owners, talk about how continuous integration means that you can actually ignore code for 6 months or a year and then run tests against newer libraries, newer environments, and make sure everything still works without having to start over from scratch. And also discuss how the monthly costs, especially in the case of a hosted service, can be small and flexible, and that the financial risk is easy to mitigate as it comes up. So if there is more that you're interested in, check out these links. We'll post or link again on Twitter to these slides. They're up on GitHub. We have various installers and scripts for automatically integrating your projects with a variety of tools. And Juampy has written a series of articles as well about continuous integration in Drupal 8. Is there anything else, Juampy, that you wanted to wrap up with?
No, not really. Let's hear there are some questions.
Yeah, that'd be great.
Yeah, so first of all, thank you very much for that really in-depth presentation. I think this has been one of the most in-depth presentations that we've had on our webinar so far. And yeah, if our listeners have any questions, then now is the time to type it in. But I think you've sort of anticipated all sorts of questions and looked at it from all different angles. So if we were to sort of ask you for a personal preference of, let's say, given a project of an enterprise size, like a big project that you're on, which would be your choice of CI framework as such after everything that you've seen and experienced and sort of worked with?
Well, I said before my personal experience, I would say whatever size, just go with CircleCI. In my case, because it's simpler than Travis. In just a matter of minutes, you can get feedback. And besides, the installer that we mentioned in this last slide, that's a repository that contains a command that you can copy and paste at the root of your Drupal 8 project, and it will download the dependencies, it will download some sample tests, it will give you everything for you to commit that, push that into your repository, and then after you authenticate yourself against CircleCI, you'll have jobs and you'll have feedback. And that's something for you to start working from. It gives you a very good foundation, and it saves you a ton of time.
I think the other thing to keep in mind is, as much as possible, we really try to keep I'll say the test logic and the test setup outside of provider-specific configuration files. We really want the CircleCI configuration to only be concerned with what is CircleCI specific. And then as soon as you get out to something relatively generic, like running Behat tests, you should be able to run that part on any provider that supports Docker, for instance. And so, the relative risks of choosing the wrong environment, especially in a hosted software as a service scenario, is pretty low, because if you decide you really don't like CircleCI, you're not having to completely change how your tests are run and rewrite them from scratch. You could basically just add the .travis configuration files, which then themselves run out or reach out and run the same commands that CircleCI is running. So I think that even if you're totally starting from scratch, that's a really good way to approach these sorts of things, because not only does it mean that you're a little bit more provider agnostic, but in the case of a tool like Travis or Jenkins, where you don't necessarily have the ability to run the tests locally, you're really, really close to being able to do that.
All right. So another question that I have got is, would Jenkins be a good setup for small projects? And if not, which one would be a better setup? Is that also CircleCI? Or, I mean, can Jenkins be effectively used for, let's say, smaller projects?
Andrew, I don't mind. Would you like answering that one?
Yeah, I mean, I feel like it depends what your maintenance model is. Small projects using Jenkins, it makes a lot of sense if you have non-Drupal, totally unique projects that you need to manage as well, or just jobs that you need to deal with, which are outside of just, say, building your website. We like to say the best continuous integration tool is the one you already have. And if someone else is going to maintain Jenkins for you, and it's not going to cost you very much to support that, then absolutely, it's good for small projects. I think with the smallest projects that are out there, really consider seeing if you can have a public GitHub repository instead of a private GitHub repository, because then you don't have to pay anything ever, because all of these projects really want to have people test them out and get the marketing benefits from public projects using their services. So, in the case of, maybe you're writing a small custom module for a nonprofit website, make that its own little repository in GitHub, write your tests for that module, and you don't have to pay for anything, regardless of what you choose. And I would say that if you're not, if you are a freelancer doing individual websites and so on, I do think a software as a service solution is the way to go, simply because you can turn it on or off as your clients see fit. You don't have to worry about being locked into maintaining a Jenkins server forever.
Understood. So I think we've sort of run over time a little bit already, and I know that one of you is on a very strict sort of timeline here. So I think now would be a good time to sort of wrap up. And I would like to tell our listeners that if you have any more questions, you can write them to us at webinars@srijan.net, and we could take them up with the speakers and get you the answers. Or you can directly put your questions to them on Twitter, and I'm sure they would sort of give you your answers. And let me also tell you that the entire webinar session recording will be in your inbox along with their presentation by this time tomorrow. So if you want to go over certain portions, if you think you have missed something, then you can of course go over it all over again. So with that, I think we would come to a close of this session. Andrew and Juampy, thank you very much for joining us and taking out the time to do this for our community. And all our listeners, thank you for joining us today.
Thank you for hosting us.
Thank you.
Thank you. Bye. Good night.
Bye, everyone.
Goodbye.